In this example, we have a network of resistors connected to a 16-volt battery, and here this 1 ohm resistor, that is the internal resistance of this battery. We need to compute the equivalent resistance of this network, then obtain the voltage drop across each of the resistors. For this, we can solve by first reducing the network into a single equivalent circuit. This can be done by simple series parallel network reduction. For this, what we do is, first step, it is obvious that this 5 ohm and this 3 ohm are in parallel. So first we will combine these two. So let me take it as R1. So this I will take it as R2. So this I give the name as R3. This is R4. So to combine R1 and R2, I will use the formula R equivalent is equal to R1 into R2 by R1 plus R2. So that gives five into 3 by 5 plus 3. So that will be 15 by 8. So you do not reduce the fraction. So final stage, if you want, you can reduce, or you can keep it as it is. So then the modified network diagram will look like this. The 16-volt battery, we are keeping it as it is. So this is the equivalent resistance, 15 by 8 ohms. And then you have the 2 ohms as it is. and then you have the 1 ohms. So now all these resistors are in series. So as you know, when resistors are in series, you can just add them together. So meantime, this is the equivalent resistance. So this is R3, this is R4. So all these can be added together into a single value. As they are series, we can just add them together. So now that this 15 by 8, that can be written as 1.875. So R equivalent is equal to 15 by 8 is equal to 1.875. So now I will combine all the series resistors together so that you will get the circuit can be remodified like this. So this is the net resistance, so that you can compute like this: 1.875 plus 2 ohms, that is this resistor R3, then you add R4 also. So finally you will get 4.87. So that is the net resistance here. So now to find the voltage is 16 volt. So you need to find the current supplied by this battery. So this is positive, this is negative. So to find the current supplied by this battery I, so you know that I is equal to V by R. So here voltage is 16 and the net resistance is 4.875. So that you can divide by your calculator and you can find what is the value of I. So that is the total current supplied by this battery. So now once you find the total current supplied by the battery, then you may go to find the voltage drops in each of the resistors . Now that for this circuit we have found the total current supplied by this battery, that happens to be 3.28 ohms. So the next stage, we need to find the current across this resistor R1, then resistor R2, then across the 2 ohms resistor, then current flowing through the resistor R4. So for this, I am naming these nodes. This node I call it as A, and this one as B, and here I am giving the name C, and you can also name this point as D. So now it is obvious that the nodes A and B has got the resistors 5 and 3 in parallel. So that is, across the nodes A and B, we have 2 resistors in parallel. Therefore, the voltage drop across these 2 resistors has to remain the same. Hence, in order to find the currents, I start with this equation: I1 R1 is equal to I2 R2. So I1 is for the resistor R1. Similarly, I2 is across the resistor R2. The current flowing through this resistor R2, I give it as I2. So now I write this equation: I1 R1 is equal to I2 R2. Then